Good morning, students. Today we will study the main topic, actually differentiation. Till now we have studied continuity and differentiability just by checking method. Today we'll study and definitely we'll extend the study of differentiation because last year we started that. We had initial knowledge about the differentiation. We'll study today further. Let's watch what we are going to study. We are studying today. First, let me speak something about the differentiation of some functions which you already have known. Suppose you have y is equal to function, any function. So, differentiation of y with respect to x is actually dy by dx is equal to limit h tends to 0 f of x plus h minus f of x upon h. This is actually first principle. And you remember that we derived all the formulas last year by this particular formula. And after proving all the functions, like first function we took sine x or something like, so we have a d by dx of sine x, we got cos x, d by dx of cos x minus sin x, that is a previous knowledge. D by dx of tan x, we got sec square x. D by dx of cot x, we got minus cos x square x. D by dx of sec x was sec x into tan x, and d by dx of cosec x, we got minus cot x cosec x. These were the laws. Furthermore, we had some important laws, which is I am writing here especially d by dx of x to the power n. So please understand about x to the power n, where n is any number meaning any positive or negative or any real number maybe. So that time only the differentiation of that kind of function is nxn minus 1. That is a well known. Power will come front and then the 1 decrease from the power nxn minus 1. Based on that, I have some special formulas like d by dx, suppose 1 by x coming. So it is actually a formula, but we want to see as a actually it is a question and we want to say it is a formula. How we can do this? Actually, we will first write 1 by x as x to the power minus 1. Then use a law that power will come initially and then 1 decrease from power. It will be minus 1 x to the power minus 2, and after 1 we can write that term as 1 by, we just put in a denominator side, we transfer in denominator side, the power will be positive and then answer will be minus 1 by x square. So ultimately I want to speak that don't do all the work and directly remember that it is a minus 1 by x square. So it's a formula. Now we'll keep remember always 1 by x is equal to minus 1 by x square. Further, we have again important thing, d by dx of over root x. This is again an important formula. How it is? So look at it's a general method is what? Power half, then power will come front, 1 decreased from the power as a formula. 1 by 2 minus 1 is a minus 1 by 2. When 1 x to the power minus 1 by 2 will transfer in denominator, it is getting positive sign. And 2 x to the power 1 by 2 will be written 2 root x. So it's a formula. Now we won't do all the method and we will write the formula and speak along with me. It's a 1 by 2 into same. 1 by 2 into same. So it will be helpful to you only. These were two. Whenever the term will come, we won't use whole the method and we will treat as a formula that 1 by x whenever it will come, instead of that you will write minus 1 by x square. Whenever over root x with the differentiation come, you write only 1 by 2 over root x. Okay. D by dx of only x coming, if it is only x definitely it is in having power 1. So according to formula, 1x 1 minus 1 will happen. So 1x to the power 0 will happen and definitely it is 1. So ultimately I would speak that it is a 1 answer. So keep remember, alone x always differentiation, the differentiation of alone x always 1. The next is only d by dx of constant term, very important. Definitely it is without x, so there is no change. Whenever x will change, there is no change in c. And when no change in c, we'll say this is 0. So d by dx of constant term always getting 0. And what is how we can identify the constant term? Definitely it should not be x. Sometimes student can confuse about. If I write x to the power 5, I ask you what is the answer? Definitely x to the power 5 have an answer 5x to the power 4. That is simple. 5x to the power 4, that is simple. But instead of that only, if I write d by dx a to the power 5, a to the power 5, student used to speak because he or she knows this formula. So always comes image of the same formula and he or she applies the same formula here only, and she or he used to write 5 a to the power 4. But they must know that it is not a variable, it is a constant value. Even it is looking like that, it is looking like that. Here it was a x, so that we use this formula, but it is not x, it is completely constant, it will be just 0, it will be just 0. So that is important. One more thing I want to explain, that whenever any constant comes with the term of x, suppose x to the power 5 coming here, c by x to the power 5 coming here, so don't afraid, c is a constant value, but you know that differentiation of constant is 0, but it is coming along with the x, either in multiplication or in division. In both cases the differentiation of c will not be 0 because x is coming along with that in denominator or in numerator. So that time only happen, you can take out c outside, take out c outside the d by dx, and only 1 by x to the power 5 is remaining there, and now differentiate 1 by x to the power 5. By transferring x to the power 5 in the numerator, it will be x to the power minus 5, and use this formula. So this is only the things with the board is very important. This is the first principle which we used last year. We did all the derivations by this, and you remember that we found all these formulas by this particular. So okay, this was in the beginning. Already have discussed today also. Now students, these were the formulas we'll study next. And the study is differentiation of composite function, or we can say function of function. Differentiation of function of function. That is important study, and you heard it about it. I know it. So, what kind of that question? Chain rule I taught the last year. To this year I won't discuss all. We'll go through the direct method. What is the method? Let me speak something. Suppose you have a question: y is equal to sine x. Suppose I'm not writing that, only d by dx of sine x. If I ask this question, so definitely you have an answer. D by dx of sine x is cos x, we know it. But instead of that only, if I ask what is the differentiation of sine of cos x, so what is its answer? Okay, if you are feeling tough, let me change it. Suppose it is coming only 5x. So students see these two functions, and just imagine that, or think about, this was a sine x, so answer was cos x, but this is just a bit changing the function of x. This was x, but it is not x, it is a 5x. This time the function definitely in x it is, so x changed by 5x, bit change happen in x. This time it is looking same as it is, but the answer of sine x was cos x. You are expecting that differentiation of sine 5x will be only cos 5x, because it looks same, it seems very same, but it is not so. You have done actually half answer. It is not so. It is not an answer. So what the answer is, let me speak something very frankly. It was sine x single function, but instead of x, if you supposed to have any other function, two functions will be counted. First is a sine and second is a 5x. So this time you have to make the chain. Actually chain rule is already there, but it is a very, in last year I discussed each and everything and told you that chain rule is actually a very long method, by increasing the number of function, the procedure of chain rule also extend. So we don't want to discuss about all. We will study the fundamental and direct method. That is very helpful and useful. Look at sine of 5x will be counted two function. First is a sine and second in 5x. So by chain rule, we will do first differentiation of sine and then 5x. First is sine, second is 5x. So how we differentiate? Definitely first will be sine. So differentiation of sine is cos. It was x, so definitely it is x. It is 5x, definitely will be 5x. But this is first will be differentiate as a cos, but angle is same. Sometimes student write x, that is wrong. Whatever the big function is there, whatever the change function is there, you have to write with the cos because it was an angle of sine. It was an angle of sine. You have to write all same angle with the cos. Differentiation of sine you have done. It is not enough. You have to use the multiplication sign because by chain rule, if you have a two function, you already recognized or identified that there is a two function in continue way. First sine, second 5x. So you have done the differentiation of sine as a cos with same angle, and d by dx of the new function will happen, which is 5x. Look at, very simple. So first you have done of sine and then you the chance of 5x. So what the answer is? Definitely cos of 5x is unchanged and d by dx of 5 into x is coming. So you don't worry. It is 5 is a constant is coming along with x. So right now or recently I taught you that whenever the constant is coming with the function of x either in multiplication or in division, the differentiation of 5 will not be 0. It will come out as it is and d by dx only will happen x. And alone x, whenever it comes, the differentiation of x will be 1. So answer is with you, cos of 5x into 5 only, and that is 1. That's an answer. Okay, I don't rub this and want to put one more example for you. Suppose the question comes sine of 1 by x. You don't have it. Very simple question. Sine by and 1 by x. What is the change in that? It was sine x. So answer is cos x. It's a sine of 1 by x. Definitely two function is there. First is a sine, second is 1 by x. So we do same. First I'll treat to the sine. So what is the differentiation of sine? Cos. So I'll write cos of same angle, and then because you have done till now the differentiation of sine by the chain rule, first it will happen sine and then 1 by x. So d by dx of 1 by x will happen next, and definitely cos of 1 by x will be same, and d by dx of 1 by x I taught directly. I made you write here in that section that 1 by x whenever it will come, the answer is minus 1 by x square, and that's an answer. Okay, furthermore, one more example I want to take. Suppose question comes with the procedure. This time I wrote the answer with d by dx directly, but now I am writing some special way. Suppose question comes, find dy by dx, and question is with you, y is equal to sine of cos of x cube. Now think, before beginning the question you have to think that how many functions there are. First is sine, second is cos, and third is x cube. If you supposed to have only x, then only two functions. First is sine, second is cos x. But see that it carefully, it is x cube. So it's a three function there. First is sine, second is cos, and third is x cube. So one by one we do all the differentiation, and we will write, look at the language, differentiation of y with respect to x. So this will be written dy by dx. This will not be directly differentiated, but you have to write symbol d by dx. And now it's time to differentiate. Now how you will do it, I taught you. First it will be sine. So differentiation sign is cos. Look at, when I will write cos, whole angle will come under it. Angle is cos x cube. So same will come. This is a differentiation of sine, which is cos, and angle will come same. This is only the differentiation of sine we made. Now it's chance to differentiate this function. So d by dx of cos x cube will be similar. Now first you have done the sign differentiation of sine, angle was same. This is done of sine. Now it's time to do this. Now according to chain rule, we have met sine. Now it's time cos. So it will be same, no change at all. No change at all. Now what about that? We have again chain rule, first cos and then second x cube. So what is the differentiation of cos? Same as cos minus sine. So the differentiation of cos is minus sine, angle will be same. So keep remember, angle always gets same. And then you have done the differentiation of cos. Now it's time to differentiate x cube. So you know it's a chain. First you have done the sine, differentiation of sine, then you have done the differentiation of cos. Now it's time differentiation of x cube. And the last answer is minus. I am writing here that only the decoration is the buttering only here remain, and that x cube is equal to 3x square is being there. X cube, the formula of x to the power n. Power will come front and 1 will reduce from the power. So whatever it is coming with you, it is the answer. You can decorate finally by your will. That 3 will be written in first in x square and then so on. So this is an answer. Hope you have got the method, and this always apply with all this kind of questions. Okay, let me take some good question, not from book but from my side only. Look at them. Look student, I ask you one question, one more question, very importantly. Sine of 5x. This is a question. Sine of 5x. This is a question. So before starting the question, I want to write that question by this way. So when I will write this way, you can identify the way. Sine x to the power 5. So think it is you know first before starting the question, you should think that this function is coming in the under which function, which type of function. When I taught you the differentiations, all differentiation. So to which you will call the first function. Do you think it's a function of function? Yes. Because when question is x to the power 5, you can do by 5x4. But look, these two questions, you will feel that it is a function of function. Why? Because it was x to the power 5 and instead of x, it is sin x. And if you are thinking that, sir taught, or definitely I taught you that it is a power 5, power will come front, power, it will deduce from the 1 from the power. It is the answer, but it is not the sufficient answer. Because why it is not answer? Because it is a function of function. And how we identify it? When x is coming, only x is coming, answer is sufficient here. 5x to the power 4. But instead of that x, if it is coming some other function, you have to follow the chain rule. So how will count the function? First is the power and second is the sin x. Two function is there. So first I will differentiate to the power and then second sin x. So how I do? I use the same formula. Power will come front. 1 decreased from power. That is happening. That has happened of the power, but it is not enough. Go with differentiation of that new function sin x. And answer is 5 sin x to the power 4 cos x. Sin x, differentiate sin is cos x. You also can write this particular term as sin to the power 4x, because same, both are same. So what have you till now you have seen it. I want to do this question without writing that sin 5x as this one. I want to do this question, and it is interesting. Look at, if I write question again, same question. Now image, or normally till now the image has come in your mind. Already it is made in your mind that what happened here. So do the same procedure here. Look at it is sin 5x. I wrote sin x to the power 5. Now don't write here sin x to the power 5 and do directly. So how will do it? We have to count the function. So first function I told it is power and then second sin x. Now make a habit to speak same. First function is power and second is sin x. Actually it looks some different, but you have to make the habit that it is x to the power 5. Instead of x, what coming? Sin x. It is x to the power 5. Instead of x is coming sin x. So first function will be power and second will be sin x. First function will be power and second will be sin x. So what I'll do? Power will come front, one decrease from the power, and then differentiate of sin x. Sometimes student could not think so, because when he or she will write like that, the image will clear. But this time you have to make the habit, because all the time I won't allow you to write like that. It is not wrong, but I think student you have to understand that first power will come front, one will decrease, and then differentiate sin x. What next happen, you know it, 5 sin to the power 4x, and differentiate sin is a cos x. So keep remember also this method, it is again very important. Look at, I do one more thing in quick manner, that is again very important to you. Look at, we know that d by dx of over root x is 1 by 2 into same. That only I made you write all. Instead of that, I just, because when I told you this formula, I told that it is actually a question, but I made it formula. And based on that, if suppose you have a question like root sin x, so how you will do it? So I wish that you do by this method, because it is the same function. Now you can count as a function. So I simply teach you that count number of function. First function is a over root function and second function is sine function. It looks same. It is only the function because x was there. But instead of x supposed to come sine x, it will be counted as second function. So first function is over root function and second is a sine x. So according to chain rule, I do differentiation of root function and then differentiation of sine function. So what is the differentiation of under root function? 1 by 2 into same. So I will write what? 1 by 2 into same. Same meaning that whole. Look at 1 by 2 into same. So 1 by 2 into same. But it is not enough, because we have counted two functions. First was under root, that happened only as a differentiation, we got an answer. And then second will be only differentiation of sine x. And now the answer is with you, 1 by 2 into sine x, and differentiation sine x is cos x. And that's an answer. So hope you have got the method. Now I stop my video here, and I request you, do question number 1, 2, 3, 4 and 7, also 8 from exercise 5.2. Thank you.